Hi there. I want to thank you for taking the time to watch this video and prepare your best for the upcoming 2A test. Let's get to it. Number one, we're looking for domain range of the relation and determine whether it's a function. Domain, remember that goes with your x's, and range goes with your y's. And as a reminder, if you're not sure, if you get confused, just think about the alphabet. D comes before R, X comes before Y. You can kind of match them up that way. So when you have just points, all you got to do is list the X values and put them in order. We use these funky looking brackets. You don't need to do any repeats. So I see there's two ones. I don't need to write those twice. And I see there's a -3 is my smallest number. And then there's a 1 and a 2. So we got 1 and then there's 2 right here. So there's the domain. It's just those specific points. And the range is your y's. So you're just going to list your y's here. Again, you don't need to repeat anything. And so there's only really 3 distinctive y's: -2, 5, and 7. -2, 5, and 7. And then if you want to know if it's a function or not, basically looking for the same x going to different y's. And I've got that here. I've got 1, 5 and 1, -2. Though that's an issue right there. This point right here and this point right here, that can't happen. So this is not a function. Remember, you could see that on the vertical line test. If you get stuck, you can graph your points. So like here's 1, 5, 1, 2, 3, 4, 5, and then 1, -2. Here, and see a vertical line goes through those 2 points. That's when it's not a function. Okay, it's okay to have the same y with different x's. So these two in the middle, this is okay. That could happen just fine. But it's the same x going to different y's. That's the problem. All right, next problem. You did some delta math practice probably on this right here. Here, it's more than just points. It's more than just a specific number of points. This is an infinite amount of points because you got arrows at the end, and it's all connected. So I mean, there's all points in here. These are all points. So you can't list them all because there's just too many to list. So when it's like that, you can list that your answer is an inequality, or in delta math, they showed you how to do interval notation. Okay, so here's what we got for domain. Domain is the x's. So domain is your left and right. So you ask yourself, if you were going for a ride on this particular graph, how far left do you go? Well, it's got an arrow, so this really just keeps going forever and ever and ever. They just stopped drawing it. And how far right do you go? Same thing, it's going forever to the right. So you're always going to be going to the right, you're always going to be going to the left. Domain is going to be all reals. So you could write all reals, you could put this big looking R, make an 11 turn into R. If you did interval notation, I don't know how many of those you had, but you basically would say negative infinity is how far left you go, and positive infinity is how far right you go. And you can never equal the infinity, so you'd always use the parentheses on those. Okay, so that's your 2 possible answers for domain, or you could write all reals. Range is your up and down. So if you're on this ride right here, how far down do you go? Well, the low spot is right here, and it's at a level of -1. You're down 1, but then it goes up forever, right? So here you want to label your low number first, which is -1. And then it can equal -1 because there's not an open circle right here. If there's an open circle, you just put less than, but we'll put less than or equal to. And then I'm going to use y's because it is up and down, so there are y's. And then I guess that's it because it goes up forever, right? So -1 is less than or equal to y. There's no upper boundary, so that would be a good answer. Some of you might write it the other way and just say y is greater than or equal to -1. Maybe you feel better about that. Either one's good, okay? If you were going to do interval notation, you would write the small number first, which is -1. And then this one goes forever, so you put the infinity. Remember, the infinities have a parenthesis. The -1, since it can equal, you distinguish the difference by putting a bracket. So if you want to do interval notation, we're perfectly fine with that. That would be your answer for that. Is it a function? Yeah, it's a function, and the easy way to tell is that it passes the vertical line test. If you draw any vertical line, and move it around. You can't hit more than 1 point anywhere. Sorry for my messy line, but it only hits 1 point on the graph at any one time, so it passes the vertical line test, so it is a function. Okay, moving on. All right, number 3 and 4, you've got two functions, two different equations, and then so you just got to know when to use which one. 3 says this is read f of 4. That just means use the f of x function. So you're just plugging in 4 like you did in chapter 1. Right? You had problems like this in chapter 1. It's just here it's a little different. It's just different notation. Do your order of operations. You do 4 squared is 16. After you do the square, you're going to multiply. 4 times 4 is 16. So you'd have 16 plus 16 is 32. Just work left to right with the plus minus. And 32 minus 7 is 25. G of negative 2 just is telling you to use the second function. Okay, so you're going to plug in negative 2 for x. Negative 2 minus 3 is negative 5. Absolute value of negative 5, well, how far is negative 5 from 0? It's 5, right? You just switch it to positive, keep it positive. So you should never have a negative absolute value. And then 5 plus 4 is 9. Now, don't get confused. Sometimes kids are like, they think this is an equation and they divide over the negative 2. That's not how it's done. This is just our answer, 9. Okay, this is not an equation to solve. It's just telling you what to plug in. Find the slope. Okay, well, slope is y minus y over x minus x. It's y2 minus y1 over x2 minus x1. But don't get hung up on that. I mean, you don't have to say that my second point is x2, y2, because I could have rewrote these in this order right here, and it would be the same line. Right? So it doesn't matter. You just have to be consistent with your x's and your y's. And so what do I mean by that? Well, first, on this one, I actually would have started with 6 minus negative 1, just because I know that's going to give me a positive. So I like to start with the positive. Have that positive attitude to start with. But then on the bottom, I don't have any control. So I can't just make it positive. I have to be consistent. So if I start with a 6 for the y's, I have to start with the negative 3 for the x's. So I do negative 3 minus 6. 6 minus negative 1 is 7. You got to add. Right? Minus the negative is plus. Negative 3 minus 6 is negative 9. And now when you have one negative in a fraction, you don't need to keep it on the bottom. You can just put it to the side, or you can put it on top. One negative, you can put it anywhere. Number 6, I would probably go this direction because that's going to allow me to make my top number positive. Then I need to go this direction here and have 8 minus 8. 3 minus negative 5 is 8. 8 minus 8 is 0. Now don't leave 8 over 0 as an answer. Or if you happen to, if these numbers would have been switched around, you got 0 over 8, don't leave 0 over 8 as an answer. You need to decide, is your answer either 0 or undefined? Okay, and I mean, if you're not sure, put it in your calculator. If you do 8 divided by 0 in your calculator, you're going to get an error. If you do 0 divided by 8, it'll say 0. So this one, you need to be writing undefined. If you leave 8 over 0, you're not going to get full credit. Okay, 7, we're going to write in standard form with integer coefficients. Make sure you know your forms for the test. Standard form is ax plus by equals c. Integers means you're not going to have any fractions, so you can see we have a fraction over here. So I always encourage kids to get rid of the fraction right away. You can do that by multiplying by the common denominator, which in this case there is only one denominator, so multiply by 5. Going to multiply each term by 5, so it wouldn't just be y now, it'd be 5y. And then 5 times a fifth is 1, so you just have x. That's why we did it. 5 times 1/5. You can cancel the 5s. That's my preference. Otherwise, if you multiply straight across, you'd add 5 over 5. That's just 1. And then don't forget to take 5 times the 8. That's a common error there. We're still not in this form right here because the x is on the right. So I'm going to minus the x over. Negative x plus 5y equals negative 40. And technically, this is in standard form. We have been having you write it so that the x is positive, though. So it would be nice, or you didn't know for sure anyways, but it'd also be nice if you would switch the signs and then you have the same equation. So if you switch this to x minus 5y equals 40, it's the exact same thing. It just looks a little different. Okay, be really aware of the forms on the test. So number 8 is asking for point slope and standard. So make sure you know what point slope form is. It's basically the slope formula rewritten. Right, here's our slope formula, y2 minus y1 over x2 minus x1. It's just x2 minus x1's multiplied over, and you don't have x2 and y2 because this is x2, y2 is a specific point. You want to represent any point on a line. That's why we don't have x2, y2, we just have xy. Okay, so I would plug in there first. So I go y minus, I only have one point, here it is. What's the y coordinate? y1 is 4. Slope is -2. And then make sure you do minus, the x coordinate is 1/3. Okay, this one's kind of tricky. I can see doing it a couple ways. I'm sure most of you are going to want to just distribute, in which case you'd have -2x. And then positive, what's 2 times 1/3? It's 2/3. At this point, and we could have did it up here, at this point I'd multiply everything by that denominator like we did in an earlier problem there, so that you get rid of the fraction. Okay? Or you could add 4 and write 4 2/3, but we want, when we do standard form, we don't want fractions. So I'm going to multiply by 3. So that would give me 3y minus 12 equals -6x plus 3 times 2/3 is just 2. Just cancel the 3. Okay, so now you want to add the 6 over to the left. So that'd be 6x plus 3y, right? If I add 6x, sorry, I'm running out of room. And then, but they got to bring the 12 over to the right. So I want to add 12, and over on the right you'd have equals 14. So my standard form is 6x plus 3y equals 14. I highly encourage you, take the point, your point 1/3 and 4, plug them in, you can use your calculator, and make sure you get this answer at the end. If you didn't, you know for sure you did something wrong. If it is right, you're more than likely right. It doesn't have to be, but if it's wrong, there's no way you're right. So 6 times 1/3 is 2. 3 times 4 is 12. 2 plus 12 is 14. See, I feel pretty good about this now. And then the point slope form we actually had right here, so we could have written that down right away. Make sure you know your forms. All right, I'm going to write equation of a line again, and it's going to be in point slope. So there's my y minus y1 equals m times the quantity, x minus x1. And we want to be parallel. So that says parallel right there. All right, see the word parallel? And from that, you need to know that parallel means same slope. So this is the line that we're using. The only thing I care about this line is its slope. And its slope is -4. I know that because what form is it in? It's in slope-intercept form, which is y equals mx plus b. And the -4 is in that m position. Okay? So I want parallel, so I'm going to use -4 along with this point. And it says point slope, so I get to just use this one again. Please study these so you have them down. I go y minus, what's the y coordinate? It's -3. I want parallel slope, so it's -4. And then we do x minus the x coordinate, which is 2. And I said leave it in point slope form, so we're basically done. I'd have you change y minus 3 to y plus 3. That would look nicer to me. Well, that'd be a good answer there. Had we said perpendicular, then what slope would we use? Well, hopefully you know the perpendicular slope is flip it over and switch the sign. So then we would have had a 1/4 over here, but it said parallel. All right, 10. Write the equation of the line through each pair of points. First write it point slope, then slope intercept. All right, so point slope's always the easiest one to get to. Here we have 2 points. So in order to go to point slope, I need slope. So we got to go back to what we did on the first part of the test here and find slope. We got to do y minus y. I would start with the 6 because that's going to allow me to have a positive on top. I like that. And this one's really nice because when I follow that order, I get a positive on the bottom. I like it when that happens. So this would turn into positive 8, 6 plus 2, and this would turn into positive 6. Reduce that, the slope is 4/3. Okay, so point slope, you actually have options on this one because there's 2 points. You can use the 4, 6, or you can use the -2, -2. If you use the 4, 6, you would have y minus 6 equals 4/3 times x minus 4. If you use the -2, -2, you'd have y minus -2, which is y plus 2, equals 4/3. And then x minus -2 is x plus 2. Okay? So either one of these are good answers for the point slope. Slope intercept, though, you're going to get the same thing. I'm going to go ahead and use the y plus 2 equals 4/3 x plus 2. So we're going to slope intercept. You could distribute, but then you get another fraction here. You're gonna want to probably, I don't know, it's up to you. You could distribute, get a fraction, and then just use your calculator to get the rest of the answer. Or I like to multiply everything by 3. By everything, I mean both sides. So I multiply the left, I get 3y plus 6. And when I multiply the right, you got to be careful. You don't multiply the inside of the parentheses, you just take it times the 4/3. Right? Because really what you're doing is 3 times 4/3 times x plus 2. So you need to multiply, you can multiply any 2 things first and then multiply it by the third. So 3 times 4/3 is 4, and then there's an x plus 2. Okay. That takes care of the fraction for now, which I like doing this because if I want to go to standard form, then I'm kind of set up for that. I've already got rid of the fraction. Slope intercept, not quite as big a deal. Distribute. 4x plus 8, right? 4 times x, 4 times 2. Bring over the 6, so minus 6, you'd get 2, right? Minus 6, minus 6. And then divide by 3. Got to divide everything by 3. So you get y equals 4/3 x plus 2/3. That'd be my slope intercept form. If I got rid of the fraction first, that's the steps I'd take. If you were just like, I don't want to do all that because I'm pretty good with fractions, then you could have just distributed first, not had this 3 out here, and just had y plus 2 equals 4/3 x plus 8/3. 4/3 times 2 is 8/3. And then you'd have to subtract 2. Okay? Well, 2 is the equivalent of 6/3, right? 6 divided by 3 is 2. So if I subtract 8/3 and 6/3, do you see I get that 2/3 again? So you could have done it that way too. Up to you. All right, 11. Find the slope of any line that is perpendicular. All right, so here we have perpendicular. So now that's going to be that flip it over, switch the sign, the negative reciprocal or opposite reciprocal. First, I need to find the slope of this. So to do that, I would get the y alone, put it in slope intercept form, probably the easiest thing to do. All right, subtract 4x, divide everything by 8, and then you get, let's see, I want to put an arrow, not an equals there. You get y equals -1/2 x, right? 4 over 8 is a half, so -4 over 8 is -1/2 x. And then you get plus 2. The plus 2 doesn't really matter because I'm just trying to find the slope of a line that would be perpendicular to this. So the slope of what we have is -1/2. So the perpendicular slope would be flip it over, switch the sign, 2. Okay? So the slope of the perpendicular would be 2. All right, so 12, find the x and y intercepts. You can find x and y intercepts by just plugging in 0. So when y is 0, you found an x-intercept, and when x is 0, you found a y-intercept. So if you plug in y is 0, this is what you're left with right here. 6x equals -24. You just divide by 6, and you get -4, right? -24 divided by 6 is -4. Okay, well that is the x-intercept, right? So if I told you to graph -4, 0, it'd be on the x-axis. So that's an x-intercept. Make sure you put it in the right spot over here. It's not a y-intercept, it's an x-intercept. And then if I want to find the y-intercept, I can plug in x is 0 and divide by -3. And -24 divided by -3 is 8. So the y-intercept is an ordered pair, 0, 8. So if I was going to graph this, I'd go up 8, and I'd draw a line, right? So that's another way to graph a line. Okay, graph of y equals x. Basically, that's saying, like, if x is 0, y is 0, and if x is 1, y is 1. If x is 2, y is 2. If x is -1, y is -1. It's this line that goes perfectly diagonally through these first and third quadrant. I don't know if you remember that from the past. Otherwise, you could have said the slope is 1 over 1, and the y-intercept is 0. So you start at 0, and then you go up 1, 1 right, up 1, 1 right. So you're drawing your best straight line through here to represent y equals x. X equals -3. You want to make sure you know your y equals and your x equals. X equals -3 is right here, and some kids will just put a dot there. Well, x equals -3 is a line, it's not a dot. That's not the only spot where x equals -3, right? X equals -3 right here also. This is -3, 1. It also equals -3 right here. It's -3, 2, -3, 3. So x is -3 is a vertical line, okay? And what kind of slope does a vertical line have, just for a reminder? This slope would be undefined, okay? If it would have been a y equals, it'd be some kind of horizontal line, straight left and right, and then your slope would be 0. Okay, last one. So we've got some data to enter here. You got to be careful. Make sure you read the directions. This says you're going to let x be the number of years since 2000. So a common mistake would be to put year as your x, but then put 2000, 2001. Put these numbers in here. You got to follow the directions. It says x is the number of years since 2000. So you're going to be entering 0 for 2000, 1, 2, 3, 4, 5. Make sure you do that. If this would have started at, say, 2008 and then 2009, 2010, and it said years since 2000, you got to do 8, 9, 10, 11. Make sure you're doing that, okay? So we're going to write an equation of line of best fit. We're going to go to our calculator and plug those numbers in. First, you're going to make sure that your diagnostics are on so that you actually have an R value when you do your problem. Oops. Sorry about that. Just wanted to get the bottom of the screen in there for you. So make sure your diagnostics are on. If you have the new operating system or if you're using the app on your Chromebook, and if you don't know where your app is in your Chromebook, make sure you ask your teacher to help you find that. Go to mode, and then you can see diagnostics on is right where I'm highlighting. Make sure it's on and not off. And then you get an R value. Otherwise, you need to go to second catalog, and then you just keep scrolling down until you see the word diagnostic on. And then you got to hit enter twice. Okay? Once you have that activated for sure, you're going to enter your data. You're going to hit stat, edit. So just hit enter on edit. And then I've already entered my numbers. Notice I had 0 to begin with. That stood for the year 2000. After you've got your data entered, then you're going to hit stat, arrow to calc, and then number 4. There's a linear regression. We're trying to find a line of best fit. So hit number 4. Make sure you're on L1, L2, because that's where my list was. You can change it by hitting second and the number. So if I wanted L3, I'd hit second 3. I don't want L3. I want L2. So second 2, and then calculate that. And then you're going to write this information down right here. Notice the R value. We're going to go to the thousandths place, which is 3 decimals. So that'd be 0.852. 0.852. Okay, so I wrote down the equation here with the A they gave me and the B. I didn't put the X, so remember, it's in Y equals AX plus B. So the A is basically your slope. Those of you who are distance learners, when you do this problem at home, one like this, you're going to have to go to the thousandths. So make sure you go to 3 decimal spots, all right? That's why I wrote 3. It doesn't say it here, but I know on the the home test, it's going to say thousands. So this is actually what you'd write in here. I'm going to talk about the R value next. Just going to skip B for now. The R value is 0.852, which isn't, I wouldn't say it's very strong. You know, I'd want to be in the 0.9s or very strong, but I wouldn't call it weak. So I would say that this is strong positive. So you want two answers there. You want your R value, and then you want to tell me that it's what it is. And then finally, let's go back. You want to estimate the enrollment in 2013. So you need to make sure that you plug in the right number. Don't plug in 2013. Remember, X is the year since 2013, right? So take 2013, subtract 2000. You're gonna plug in 13, all right? So just go to your calculator, plug in 13 for X, and see what you get. Okay, so here I have it all plugged in. I get 3328.8. It is talking about student enrollment, so we're going to have you just go ahead and round that to the nearest. So I would put down 3329, and then I'm just going to double check to see if this answer kind of makes sense. Let's see, 3329, looks like it's going up. This tells me it's going up about 150 every year. That's what the slope means. So let's say 2003 to 2013, that'd be 10 years, right? So if it goes up 150 every year for 10 years, that's like 1,500. And if I add 1,500 to that, that's pretty close. So I feel pretty good about that answer. I feel like I typed stuff in right. All right, so that does it for your video test review. Thanks again for taking the time to do the extra practice and for watching. If you have other questions, please reach out to your teacher. Have yourself a great day.